Okay, so the first decision is the number of downspouts. We can have one. I don't recommend you do that. Four would be the minimum for this kind of building, I think. We can have 10 of them, or we can adapt our building to the shafts or our downspouts to the shafts that we already have. So in this case, we have 6 shafts, 1, 2, 3, 4, 5, 6, and we have created like 6 different downspouts. And I think that would be the right option for this one. So in the other section, we have created a different option. We created 1, 2, 3, 4, 5, 6, 7, 8, 9 downspouts. Okay, if I had to do it again, I would do this. I would create only 6. So in this section, we're working only with 6 downspouts. But now we have to do that in Revit. So in Revit, you have done this. Okay, you have done everything here, Ryan. Very good. Okay, because in the other section we didn't have this. You have created the downspouts, and then you have created the horizontal drainage. Okay, I'm going to explain that now. So for the downspout, you have it here. 1. Okay, so we're going to create 6. You have another one there. I'm going to copy this one here. So we have 1, 2, 3, 4. Well, this is what you have to be careful about. You have a downspout going through the duct. Don't do that. Okay, that's a terrible mistake. So we have to make sure that there is no any intersections between air and water and all that. So 1, 2, 3, 4. I'm going to place another one there. 5. And another one here. Oh, you already have one here.
Thank you.
Right. Okay, so 6 in all. So now in what do I have to do? If I have this layout on the roof, now I have to work on the basement. So on the basement, we don't have these, we just have the vertical pipes. We don't have the arrows and the shafts. Okay. And I even go. So now we have to connect all of them, and then we have to get rid of the water. And what's the criteria? We have to facilitate this. So I'm going to create like a first. Okay, so that will be the main branch of water, and then I have to connect all the downspouts to that. With the same criteria that I did for the drainage. Do not do it with 90 degrees T's. So we have to facilitate this with 45 degree angles. So we have 45 here. And if we have to connect 2 different branches, try to avoid conflicts and try to extend this this way. So do not connect 4 pipes in the same point. And if we want to do this, then I would need a vertical branch all the way up, and then another 45 degrees up to this point. Okay, so we can do this. It can be different. This is underground, so nobody is looking at it, so it doesn't have to be beautiful. The criteria: the less pipes, the better. The less connections, the better. So don't don't do complicated things, because the thing is that it has to flow as soon as possible. And then at the end of this, we need this manhole for the water. And then we need to connect this to the city sewer system. Like this. Okay. And now we have to calculate this element. So with this table, we have calculated that if we have, well, if this is the area, so that was a 3-inch downspout. But now we have to do the same with the horizontal element. So for the horizontal element, we have this. First, we need the slope. 1/4 is fine. So I would use always 1/4. Then the maximum rainfall in New Hampshire, it was 6. So we are in this column. And then here we have the projected roof area. Okay, so this is not the sectors that we have divided the roof. So this is the maximum roof area. So if our roof area is around 9,000, so that should be this, at least 10,000. And we go, so that should be an 8-inch pipe, okay, with that slope. So at the end, this should be 8 inches. So that's the only thing we know, that at the end, that should be 8 inches. Can it be less here? Don't save money on drainage. So if it has to be 8, make an 8-inch duct or pipe here, and then connect everything with 8 inches. If you don't want to connect this with 8, probably you can make this 4 inches. Because the downspout was 3. Okay, so this vertical to horizontal transition, it's only something important, because we are moving the water down this way, and then suddenly we have a horizontal with a slope, very light slope, but we have a horizontal element there. So there was a guy by the name of Bernoulli. Daniel Bernoulli, a Swiss mathematician and physicist that lived in the 18th or 19th century, died in 1782. Okay, so the 18th century. So this is the Bernoulli distribution, or the Bernoulli principle. Well, so he studied fluids, especially the pressure of fluids. So the energy that we get here, it depends on the height. It depends on the mass, in this case of the water, that it's going down, gravity, and that's the difference between H2 minus H1. Okay, so that's if H1 is 0, that is H. You would see this formula of potential energy, either like potential energy equals mass, gravity, a difference of height. But if H1 is 0, you can see this mass, gravity, and Z. Okay, so Z, it's the total height from this point to that point. So that means that this mass by gravity is going down. So at the end, it has this energy, and that is transformed in kinetic energy, which is a half of the mass times v squared. This is it's not v times 2, it's v velocity squared. Okay, so at the end, that's the equation. So the potential energy that we have here, because of the height of this mass of water, if it goes down, it becomes in kinetic energy, and the velocity of the water there is related to the height of the mass there. Okay. So what happens? Depending on the height, the velocity of the water here, it can be quite high. So the transition between this horizontal, this vertical, and the horizontal, it's like you leave something heavy. Okay, so it's like it's not something that it's continuous. We have gravity in buildings, and the weight is going from this floor to the foundations, but in a continuous way. But this is something that it's not continuous. We don't have the same amount of water there. So we have, it rains, and then the water goes down, poof, and that's so by doing this many times, you can end up damaging that connection. So that connection is quite important. Okay, so what we can do anyway is to, if this is a 3-inch downspout, so when it hits here, it cannot be less. And in this case, I would say that it has to be even 3 wouldn't be enough. So 4 would be better. Okay, so that's why we have to calculate the maximum or the minimum vertical stack, and then we have to calculate this one, because the tension that we have here of water hitting the horizontal branch day in, day out, it will end up affecting this. So this is always something important. And when we have this connection, we have to reinforce this so that the horizontal pipe doesn't suffer the constant heating of the vertical water going here. So we need to reinforce this elbow, that connection. So that's important, and make it wider. Okay. So this is why we have to, well, we have done this. So even if we have a 3-inch downspout, I would do this bigger. And then this main branch can be 8 inches, and those connections are between 4 inches and 8 inches there. So what have you done in Revit? Okay, you have done this, and that's fine. So you have connected this with the 45 degrees. That's good. So you have done this correctly. Instead of having like a straight line, you have done this. Okay, I don't mind. If we have a new downspout here, probably we should connect this again this way. Well, probably the height is not correct, okay? But if we have 6 downspouts, that's the thing. We have to connect this with a 45, at least with a 45-degree angle, as you have done here. And then you have even this. Okay, so that's important, and I didn't explain that before, so I'm going to explain that today. So this is a perimeter drainage around the building, and at the end, it's connected to the main rain downspout. By the way, this should be 8 inches. Okay. So all, at least the last one should be 8 inches. So I think I would make all these 8. And then that connection. Okay. So make sure that the main branch is always 8, and then this connection can be 4. But this is important because when we have a building that it's not attached, this is detached, we need to provide waterproofing to the perimeter of the building. Why? The worst possible thing that can happen to water is stagnation. So if the water becomes quiet, if it doesn't move, if it doesn't flow, it will end up entering the building. So that can happen in the roof, especially in a flat roof, but it can happen here between the wall to floor transition. So if you look at this building is quite good. So if you look at this building, let's see. But I see that in Winchester Street, the transition between the building and the sidewalk, we have like some plants or something like that. Okay, take a look at it later. And this is, okay. So this is the important thing. Okay, so this is the grade level. It can be a sidewalk, the road, or soil, or whatever. And this is the wall. We don't need even a basement. Okay, so we have the basement, but the foundation level, it's like 2 or 3 feet below the grade level, the first floor of the building. So we have to go deeper, 2 or 3 feet, and then we have to dig that trench. And you see that yellow pipe. So that yellow pipe is a drainage pipe all around the building. And then we protect the wall, the building wall, with this material. Okay, so that's very important, and we tend to forget it. Okay, so if this is the first floor slab, go deeper, couple feet, 2, 3 feet, and then waterproof all these and place this drainage pipe all around the building, because the water will filter, and if the water filters and it finds a duct or a pipe, it goes away. But if it doesn't find this, the water will stay here, and it will end up affecting the wall, and it will end up inside the building. So that's the detail. Okay, so if we have a wall here, we need to extend the waterproof until the foundation level, and then we need this duct or this pipe, and so that the water is collected by this pipe, and then we get rid of it. Okay, so do not forget this. If we have a basement, it's mandatory because we have 6 feet or 7 feet of a wall buried. But even if we don't have a basement and we have only a couple of feet, we need this drainage, and we need all this protection. Okay, so the drainage is underneath those aggregates, but we need those elements, so everything has to be protected by the water using those elements. So this is this drainage or this pipe in the perimeter. What's the size of this? 4. Yeah, it can be 4. And this is rainwater. Okay, so it's the rainwater that it's filtered through the soil. So we can mix the rainwater that comes from the roof with the rainwater that comes from the soil. Okay, so eventually we will end up connecting this to the city sewer system. But before doing this, you have met the requirements. You have one for the rain, another one for the gray water, another one for the black water, the water that comes from the toilets. But before supplying this to the city sewer, we need another element, and I think it was here. It was a Revit. Yep, you have to use this Revit on week 10. I uploaded this catch basins, whatever, which is this one. So I'm going to upload this here. And I have to place it in the right level, which is level edit work clean, -15. Okay, it's level -15, but it has to be even below that. So I'm going to the elevation, I'm going to go -3. Is it enough? I think so. Okay, so here we have out, and great, connected here. This is prepared to connect different pipes. Okay, so if we don't have all these pipes connected to the same box, we can just have caps for the rest. But the important thing is that we end up connecting this one to this one. To do this, I think we have to have the right level. I'm going to move it here. Okay, so we need this connection. So we need this connection at every for the rainwater, the gray, and this. So we need like 3 boxes like this here, and then we can move this to the city sewer. Okay, so if the city sewer is a pipe that runs in that direction, well, before doing this, probably this city sewer is something very big, even more than 12 inches. It's a maximum, but the city sewer, we're talking about 4 or 5 feet, and there's always a connection here. But this is the city sewer for water, for rainwater. There will be another one for gray, and there will be another one for the black water from the toilets. And each duct or each pipe goes to a different place. So the rainwater, we can supply this to the Ashuelot River directly. The gray water, we have to reuse that gray water, so we need a treatment plant. And for the gray water, we can't reuse the black water. Sorry, we can't reuse the black water, so we need another treatment plant, and then from that treatment plant to the river or to the sea or whatever. But this gray water is something that can be reused. Okay. So we would need like 3 different elements. And then we have to connect each element to each drainage system. Usually those pipes have different heights, but all of them underground. Okay, so we can have like 3 different levels for these 3 pipes in the street, and but this is not our business. Okay, so we end our building here, but at the end of our building we should have those boxes, and then someone will connect these to the main city sewer. Okay, so this is what you have to do. You have to do this the rain downspouts related to the shafts that we have here. Then you need to create this horizontal main branch connecting all vertical downspouts. And then at the end of this, you have to connect this to the perimeter drainage pipe. And finally, we have to connect everything to this box. And this box will be connected to the city sewer system.